All right, so let's do another example of applying Newton's method. This time we're going to solve the equation cube root of x equals 0.4 using Newton's method. Now, I know this equation can be solved just by hand very easily if you just cube both sides. And 0.4 is a rational number, so cubing that is super easy. But that's not the point here. The point is to demonstrate Newton's method. And I've selected this example specifically to demonstrate something. You can see my evil, mischievous grin over here giving some foreshadowing of what is to come. So we have an equation. As always, we need it to be something equals 0. So let's just subtract the 0.4 over, first of all. So cube root of x minus 0.4 equals 0. And so now we're going to go ahead and say, let's let f of x equal that cube root of x minus 0.4. So now that is like x to the power 1/3 minus 0.4, okay? So when we find f prime, which we were going to need in order to apply Newton's method, we'll be doing the derivative of x to the power 1/3. Now this derivative of negative 0.4 is 0, so just the first term. We're going to have 1/3 times x to the power. And then if you do 1/3 minus 1, you get negative 2/3. So we get that. So I can rewrite that, if you'd like, you can rewrite that as 1/3 times the cube root of x squared. So that's the version I'm going to use for my f prime. So now let's make our iteration formula that we're going to use on this problem. So as always, it is going to be xn plus 1 equals xn minus a fraction. And the fraction we're subtracting is f of xn in the numerator. So f is the cube root of x minus 0.4. For us, that's the cube root of xn minus 0.4. And then in the denominator, we have f prime. So that would be this thing, the 1/3 times the cube root of xn squared. Okay, so let's simplify that up before we go any further. Okay, so that we're going to have xn minus... since we're dividing by this fraction, let's rewrite that as multiplying by its reciprocal. So the 3 times that cube root is actually going to end up in the numerator. So it's going to be the cube root of xn minus 0.4 times 3 cube root of xn squared. All right, simplifying. We're going to distribute this multiplication across here, like so. Okay, we've got distribute across the subtraction here. So we're going to have xn minus, and then the cube root of xn times the cube root of xn squared. This is a 1/3 and this is a 2/3 power. If you add those together, 1/3 plus 2/3 is equal to 1. So actually the product of that and that is going to be just xn to the power 1. So we still have a 3 factor there, so it's still going to be 3, but then it's just 3xn. Now the second term here, minus, we're going to have 0.4 just multiplied by this 3, and then multiplied by that cube root of xn squared. So I believe the 0.4 times 3 should be 1.2, right? 4 times 3 is 12? Yes. So now we just have to distribute this negative through here, and then this will be nice and simple. So xn plus 1 is going to equal xn minus 3xn. We can combine those in a moment. Then minus a negative, so plus 1.2 cube root of xn squared. Okay, last step. 1 minus 3 is negative 2, so we've got negative 2xn, and then plus the 1.2 cube root of xn squared. All right, so now we have a nice simplified iteration formula to work with. Okay, so time to do Newton's method. Let's do it on the calculator. I'm not even going to bother doing anything by hand. What should I use as my initial guess? How about I just use 1 again? x1 equals 1. And then we'll go from there. So, all right, let's get the calculator out. I'll do 1. I'll try to do 1. 1, store that in x, and now I'm ready to go. Okay, so it's going to make sure it's on the screen. Yep, it's on the screen. So I'm taking 1, I'm storing it in x, and now I've got my my formula there, and I'm going to type that in. I'm going to type negative 2x plus 1.2, and then I might as well just make this x to the power 2/3. So x to the power 2 divided by 3 in the power. There we go. So I think that looks right, negative 2x plus 1.2x to the 2/3. So I'll take that and store it in x. That's what I want to do. And so if I hit enter, it's going to tell me what the x2 is. Here we go. So x2 is negative 0.8. I hit enter again, and it'll give me x3. x3 is 2.6341 ... x4, this is a bit odd. Well, I'm alternating negative to positive, aren't I? That's a bit strange. Negative 2.97946 ... x, oh my goodness. x5 is 8.4436. I'm not even gonna bother writing these down any longer. This is kind of crazy. What's going on here? Those aren't converging on anything. I'm pretty sure this just doesn't work. This sequence of numbers diverges instead of converging. So in this situation, Newton's method failed. What the heck, Newton?